Okay, in this video we're going to start looking at trigonometry, and in this video I want to introduce the trig functions and inverse trig functions and tell you how you find them on a calculator, and then I want to talk about finding lengths. So we've got some angle here, theta, which is a Greek letter. It's what most textbooks call this letter in trigonometry. And then you've got the side, the hypotenuse, which is opposite the right angle, this angle here. Because we're only looking at right angle triangles now, we'll look at non-right angle triangles later in this series. And then we've got this side here, which is adjacent to the angle theta, and we've got the opposite one over here. So then from this diagram, we've got the definitions of work functions. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. And for shorthand, some textbooks and on calculators they put trig instead of trigonometry. This sine is shortened to sin. Cosine is shortened to cos. And tangent is shortened to tan. And these are shortened as shown on the diagram here. That's why I drew it like that, just so you could see. So, first question is, how do I find these angles on the calculator? So I'm just going to do this really quick. I'm going to work the 2 decimal places throughout the video. So first, obviously, you can turn your calculator on, and then there'll be some trig functions on here. We'll have sine, so I press sine, and then I press equals to enter that in. I make sure it's in degree mode. I type in my angle, I close the brackets, and then I press equals. And I get the 2 decimal places, 0.39. So let's do just a couple more. Same for the cosine, you press cos, you type in your angle, close the brackets, and then you type in your number to 2 decimal places. Just one more really quick, just so that we can do one of each. It seems like the right thing to do. Just do it the same way. And we'll get an answer of 0.30, which we can just write as 0.3. So that's how we find these. Using a calculator. I'll just rub out this diagram now that you know what it means. Because now I want to talk about the inverse. So the inverse are written like this. On your calculator, and some are written arc sine, arc cos, and arc tan. But basically, what you're doing here is you're finding the angle that has a particular sine or particular cosine. So if I say there's an angle and it's got a sine of something like, so we've got some unknown angle, theta, and it's got let's say it's got a sine of something like 0.52. And what I could do here, to find this angle theta here, I would type into my calculator the inverse sine, which would be sin minus 1 on your calculator, and then you put in this number here, 0.52, and then you get your angle. And the angle to 1 decimal place would be 31.3. So if you put that angle in, that's the sine you'll get. So this works both ways. And just because I want to warn you that sine, the inverse sine is not equal to 1 over sine. You'll see later on in the course that that's actually equal to the cosecant of theta, which when we talk about over 3 trig functions later on. So now we're going to actually use these to find some angles. So let's look at these examples now. Okay, so on this one we're given the angle 40 degrees here, and we're told that the hypotenuse here is 10 centimeters, and we want to find this length here on the bottom A, which is the adjacent side to the angle we're given. So for this problem we're going to use the cosine. So the cosine of 40 degrees is equal to 10 over A. And A over 10, sorry, because we'll have the adjacent on the top. That's what we get there. Now, of course, we need to rearrange this formula because we want to find A. So when we rearrange this, we're going to get A is equal to 10 cosine of 40 by writing this like that and then cross multiplying. And if you know how to do that, you just cross multiply like this, like that, and then we'll simplify, that's what we get. So when you type that into your calculator, you get your answer. And the answer to 2 decimal places that you'll get would be 7.66. Let's just check that really quick and see if that's right. 10 cos 40 is equal to 7.66. Yep, that's right. So let's do 2 more examples now. Now this time we're given this angle here, but in this problem we want to find this length B. We're told that this angle's 46 and we're told that this side here is 8 centimeters, which is the hypotenuse. So in this problem we're going to use the sine, because we know the hypotenuse and we want to find the opposite side from the angle. So for this problem we're going to say sine of 46 degrees must be equal to B over 8. And then in a similar way to the last one, we can cross multiply, rearrange, and we'll find out that B is equal to 8 times the sine of 46. And then I'll type that into your calculator and we'll see what we get here. 8 sine and 46 degrees. And we're going to get 5.75 centimeters. Must always remember to put your units in. But more importantly, you must make sure your calculator is in degree mode, or these answers you get here will be wrong. Because the cosine of 40 radians is different from the cosine of 40 degrees. We'll learn about converting degrees and radians later on, but I have to tell you about it in case your calculator's on the wrong setting for some reason. So, let's just do one more example now. Now this one, the triangle's drawn in a different angle. I've just done that to show you that, because textbooks make problems like that and you get them on exams, so it's important to be able to still see and figure out what's going on with the triangle in a different kind of angle. Yeah. So we're given this angle here as 24 degrees, and we're told that the adjacent here to this angle is 11 centimeters, and we want to find the hypotenuse, which is C. So this problem, we know we want to find the adjacent, and we're given we know we want to find the hypotenuse, but we know the adjacent, so we're going to use the cosine. So we're going to say cosine of 24 degrees is equal to C over 11, and then in a very similar way we'll rearrange this, so we'll get C is equal to 11 over cosine of 24 degrees. So then we can type that in our calculator. You need to be careful when you do this one, because some calculators, if you don't put brackets around both things you divide, and it'll give you the wrong answer. So I'll type in the bottom, which is the cosine, type in the angle. Now I need to close both brackets, just in case. I get 12.04 centimeters. And that's only the two decimal places. If you cannot follow what I'm doing when I'm rearranging the formulas here, then suggest that you go back onto algebra and check how we rearrange formulas. It's very similar to solving equations really, but where everything's like a variable rather than just solving for a particular number. So that's how we'll find lengths in right angled triangles. Next video we'll still look at right angled triangles, but we'll use these functions here to find unknown angles rather than lengths.